Welcome to the Rocky Mountain AI Interest Group. The following presentation, Compound AI and the Rise of AI Agents, was recorded on January the 8th, 2025 at the Atlas Building on the CU Boulder campus. Presentations were made by David Jitendranath of the Denver AI subgroup, Luke Norris and Matt Wallace of Kamiwaza, and Gabe Spradlin of Navgen AI LLC. Chapter markers are provided below in the description field for you to navigate to each of these presentations. And finally, a big thank you to Uche Ogbuji for emceeing the event.
New year 2025, so let's get something new, agents that everyone's talking about. So as Dan mentioned, I'm an engineer, architect, etc. I work kind of like a lot of the intersection of how to get Gen AI to work in context, etc. So I've been excited about all the things we're going to be talking about tonight for a while. Can't wait, for you guys to, I think, dip into what's going to be the exciting new topic for next year. I do want to mention, a bit of self-indulgence, 2 open source projects, Tulio, which is agent related because it's basically how do you get structured information from LLMs. We got a release coming tomorrow, 0.6.0. It's been a lot of work, but yeah, that's why I've been interested in putting together this slate of speakers for you. And so is this one. Okay, so with no further ado, you've probably heard of agents, right? I'll ask a few questions, but it's like everyone's talking about agents. I love this post. Simon Wilson, he's like a well-known sort of developer researcher, and he put out on Twitter, it's like, okay, let me get your tweeted definitions of what is an AI agent. And let me also have you vote so we can figure out which ones people actually agree on. And I think when in a later thing he said, he got like 230 different, he used like automation LLMs to decide which ones were like different from each other. And he got like 230 different definitions of what an AI agent was. Furthermore, people were not voting on everyone else's, and they're like, no, that's not right. This is another one, right? So it's just to give an idea, this is something new. I mean, if you thought about it back in the 60s and 70s to define what is programming, right? It's kind of like, okay, getting a computer to do what you want it to do, right? Well, that's not telling you a lot. And I think the same thing is going on with agents. We're at the beginning. So hopefully this is a way to get people a bit more into the context. That's what we're going for, trying to figure out a little sense of what are agents anyway? So to that extent, or to that end, we're going to start with a little bit of business context. David is going to be giving us an intro. What do they actually mean in the world as they're being used, as we're looking to them as something cool for the future? Kamiwaza is going to show some really cool demos and talk about what their product does in terms of allowing people to get on board, working with agents early. And Gabe, he's kind of a man after my own heart, likes to get in, tinker, do it yourself, etc. He's going to show some really cool, hands-on stuff about what's going on with agents that you can do right now with the technology that's out there. And we will have a panel QA with everybody at the end. So, just remember that especially if you're new to the meeting, that we'll have, Q&A at the end of everything. So we'll have everyone sit in the panel and you'll be able to fire away. So, all right, well, the next slide actually is simply me saying that I want to ask you guys some questions. I've introduced myself and the people who will be speaking tonight, but let's give the people speaking tonight a little bit of context. So, first of all, who here, by show of hands, works in engineering or engineering adjacent, I would say? Oh my word, okay, it's a flood of engineers. Awesome. Who here works in business, product, or that intersection? Yeah. Okay, cool. All right, so who here is one of the 230 plus who knows what agents are? Show of hands. Yeah, come on, don't be shy. You know what agents are? Okay, that's actually fewer hands than I expected. Okay, that's awesome. We're setting the context here. This is another self-indulgent one. Who here has heard of compound AI? Almost no one. Okay, it's a term that I've started to prefer to agents because agents has that sort of what on earth are they? And anyway, so it's interesting that no one has. There was a meeting in Denver. I thought maybe more people would have heard of it, but it's another term you might find that going on as people continue to argue what is an AI agent. Okay, so who here has worked with AI agents in a professional capacity? Wow, still a lot of hands. That's wow, that's impressive. Okay, and then this is just something, a conversation that had come up before. Who here works in more broadly, not just agents, but AI research, whether it's ML, whether it's okay, so we have a few hands. Okay, so it'll be interesting to see if there's appetite for like subgroups around research, etc. Okay, well, now hopefully speakers have a bit of a better sense of what their audience is going to be. So with no further ado, I'm going to bring up David Jitendranath, or David J, as he's popularly called. You can come up. Yeah, there you go. And plug in while I introduce David real quick. Yeah, David and I had a lot of fun together. For instance, just in the AI holiday party, he runs the RMAIIG Denver group. And let's see. So, yeah, he's an AI advisor, technologist, and entrepreneur with decades of experience. Oh, okay. With decades of experience in software development, AI and solutions architecture, prolific writer and content creator on topics such as philosophy, AI innovation, self-mastery, content available on YouTube and Substack. He leads the Denver AI subgroup, and yeah, he's going to get us introduced here.
Thanks, RMAIIG, for this great opportunity. Going to bring in a little bit of philosophy and stuff like that into this. Going to start with a story from the Gothic age. So in the Gothic age, there lived this young man with amazing intellect. His scientific experiments and scientific research were revolutionary. It was so revolutionary, got him kicked out of the university. And later on in life, he developed the capacity to create life. He was faced with a dilemma. The dilemma was whether to create a lower form of life, such as a frog or a primate, or a higher form of life with human intelligence. He decides to go with creating life with human intelligence. Let's see if I can get this FX to work. It's not. Right now. It was working earlier. Oh, there we go. All right, there we go. So he decides to create life with human intelligence. And as soon as he created this life, when this life came into being, this adult body with, sort of like grotesque looking body, because he kind of collected all these raw materials from mortuaries and whatnot, he realized that he had to train, teach, guide this being to integrate that into our world, our real world. And he understood this to be this massive responsibility that he had to undertake. And the feeling he had towards his own invention was a feeling of fear and anxiety. Given this sort of a feeling, he decides to abandon this project, decides to run away from it, and this being starts chasing him, haunts him for the rest of his life. We all know this story from the classic Mary Shelley's Frankenstein. What does this story have to do with AI agents? I'm going to let that kind of pause responding to that question towards the end. We're going to revisit that question. But first, let's understand what is an agent, whether a human agent or a machine agent. What are the capabilities it has? Have to keep walking. So the first thing, there are three key tenets of an AI, or of of an agent that has agency: planning, the ability to break down a complex objective or a task into a sequence of steps. Reasoning, the ability to discern a specific path from multiple paths and choose that path and take that option. Handle interactions, interact with other free agents in the world and use tools as needed to accomplish that task. All of this is reinforced by learning, which means evaluating the results of your actions and making course corrections and adjustments. What gives us agency? Well, fundamentally, we can look to the field of psychoanalysis to gain this key insight. The key insight is language is what gives us agency. Now, if machines have language capabilities, is it reasonable to expect that someday they will have agency? Is it possible? And that is the world of AI agents that we are entering into in 2025. This is my definition. Add that to the 231st. So AI agents are a set of systems with AI capabilities that can perform complex open-ended tasks just like a real person. And the key phrase here is just like a real person. When you're working with another coworker, you don't tell them all the instructions, the steps that they have to do. You give them the liberty to make micro decisions. Maybe you'll correct them, you'll help them learn, and then you'll even allow them to make mistakes. So is this sort of going back to Uche's point? Is this something new? Is this sort of like a breakthrough in technology that we are experiencing? I'm going to start from Generation 1 agents, which some of you guys here might be familiar with workflow automation tools. MuleSoft, perhaps RPA tools, which is robotic process automation tools such as UiPath. Most of them have sort of a workflow type. It looks like a flow chart almost. You have all the path predetermined, pre-programmed. Errors and exceptions are handled. If you encounter new errors, you continue to keep handling them. And they're mostly deployed with the intention of automation. So that's what I call Gen 1 agents in the agent evolution. What sort of business outcomes did they produce? Primarily, they produced cost reduction. They also were able to we were also able to gain some efficiency, correct human errors, avoid human errors. Workforce were able to make some productivity gains because they were able to use these tools to automate their tasks. And perhaps we also saw some improvements in the customer experience side. Maybe customer satisfaction improved with some process improvements. And that's what the business outcomes that we got with these sort of strategic deployments of these BPA agents. What I want to say is the approach to all these sort of strategic outcomes where we approach them with an optimization mindset. And my claim is if we approach AI agents with the same optimization mindset, we're going to miss out on the tremendous value that we can potentially create with more of AI agents on the agentic side. What should be our mindset when we think about AI agents? I propose a value creation mindset. What would that look like? AI agents are going to be more anthropomorphic. We are going to allow them to make micro decisions. We are going to allow them to fail and recognize those failures and learn from it. We're also going to use LLMs to a higher degree throughout the various stages of the agent interaction. And what sort of business outcomes can we expect? Ability to expand product lines faster, ability to pivot easier, and what is really exciting to me personally is catalyzing an innovation economy. And what would that look like? In my slide here, I present a 3 to 5 year roadmap. And this is sort of like, I want your imagination to run wild here, if possible. So we've got the GPT provider layers with the usual suspects, OpenAI, Anthropic, Perplexity. Let's call that the intelligence layer. Above that, we're going to have millions of agents, public and private. And we could call them the AI service layer. And we're going to have users at the top, innovators, researchers, and entrepreneurs. Imagine a 10-member imagine a company that's got 10 co-founders that could be valued at $1 billion. That's very much going to be a possibility. A CMO can deploy content generation agents and gain audience. A CPO can quickly use prototyping agents, have those agents talk to retail and potentially supply chain agents, and deploy products faster and find that product market fit. Let's talk about another set of users, generalists and creatives. How many of you have here artist friends who love looking at P&L statements and P&L reports? Craftspeople, how many of you know that they love they're so excited about sales and marketing? And that's where the opportunity is. Potentially, these people could be working with small business accounting agents. Again, these are millions of agents that could be easily deployed. Small business sales and marketing agents that could be deployed for these folks. Think about communities. Who loves going to the DMV or unemployment office or a Medicaid office? We're going to have agentic robots who are going to be patient in answering the same questions thousands of times without being annoyed. That's what we're going to see. Okay, what are the challenges that we're going to encounter with this sort of an economy? Well, the first thing is pricing models needs innovation. How do agents talk to each other, and how do we price that? Obviously, we talked about private companies developing these agents. They have to be profitable. How do we make that happen? How do we pay the LLM providers, the GPT providers? What sort of interaction are we going to have? There needs to be innovation that needs to happen in that area. Talked about public and private ownership. Imagine an SBA loan processing set of agents. Should that be private or public? What about grant administration? Should that be public or private? Well, and then also, what do we choose to value? When we offload our decisions to these agents, the decision fatigue that it reduces for us, are we willing to pay for that? Software engineering needs to move more towards software creation. And we're already seeing this with software tools like Replit. I don't know if anybody's used Replit here. All right. My last slide, going back to my first question. I make a lot of videos on YouTube about AI and innovation. And my oldest son, who's 13 years old, he asked me, "Dad, you make all these videos on AI. Do you really want us to live in an AI dystopian world?" That's the question I get asked. And the short answer is no. And that's really where leaders are wanted. Advisors, educators, marketers, strategists who can work in this economy with superabundance mindset, a mindset of value creation, not a mindset of optimization, right? And my claim is this: if we deploy this technology the right way in a responsible manner, I think it will bring about a new renaissance. Thank you. If you want to connect with me on Linktree, you can scan that QR code.
So as Matt's getting that together, let me just do a quick introduction. He'll get the slides up here shortly. So Kamiwaza is not just a crazy name. It actually means, it comes from obviously Japanese. Depending on the context, it's either godlike, superhuman, or divine skill. We actually take it in the superhuman capability. That's the business context of it. So it also happens to be the name of my favorite game on the PlayStation 2 growing up, Kamiwaza, Art of the Thief. Look it up. It's awesome. So Matt and I, co-founders here, Colorado company, we launched this in February of last year. We actually came to this event and did sort of the showcase event. I think it was February, literally. Since then, we have multiple Fortune 500s. We have multiple government agencies utilizing our service and software. I'm going to pass the mic after a couple of intro slides to Matt. Matt's going to show you live demos, live services, live capabilities of actual agents running in Fortune 500 settings. And then we brought a partner here. Emma is here. Emma's with Government Acquisition Corp. They're about $1 billion plus firm that sells technology services into the government. They're one of our main partners. We did an amazing system and service for the Department of Homeland Security's Critical Infrastructure Group. And she's going to show you guys that whole service capability and what your tax dollars are going to and how AI agents are sort of revolutionizing everything. So without ado, Matt, flip to the second slide here. Next one. I already kind of covered that. Oh yeah, so he said, what is it, a 10-person team of co-founders being valued at about $1 billion. We're a 2-person co-founder team, and we're definitely on track for that $1 billion if you do the division and multiply it again. So we are hiring, not just Matt's engineers, we're actually hiring for all roles. Sales engineers, sales itself, marketing, partner management, partner relations, dev relations. Literally go to the website, hit us up. Hopefully in the next 2 days too, we'll be announcing not 1, but 2 fundings. They should be the 2 largest in the software sector in Colorado. Mix of Colorado firms and a bunch of others. So we're real proud of that. That's all going to get public in the next couple of days, but pre-announcing to you guys. So, oh, thanks. Yep, back to what's an agent. Everybody has their thing of what's an agent. Matt and I were literally live changing this whole demo, so it's going to be a little rough. We saw the amount of engineers in here, so I deleted a bunch of slides. Matt's flipped over, and he's now going to show you guys real life coding, autonomous agents, and some other stuff. So I just threw this one up. I had a whole intro to explain what our thought of the agent. This comes from my friend Guido. He's with Andreessen Horowitz. I think it wasn't it Hugging Face? This is Hugging Face's. Yes, Hugging Face's description of it. What we're going to show you today is what I would call stage 2 and stage 3 autonomous agents. We actually do have some of these stage 4 ones, the multi-agent use cases. If we come back in about 3 months, we could show those off. Right now, they're kind of proprietary, so it'd be a little hard to show. Go ahead and jump in. So real quick, just so you know what you're actually seeing today, what Kamiwaza has actually built is the orchestration layer for AI. So you can actually run private LLMs, so LLMs that you get from Hugging Face or actually have Cohere or other companies build for you behind your firewall, run it on your hardware, run it with your data across your cloud, your prem, and your edge. That allows an agent to work everywhere in the enterprise. That's why the Fortune 500s and large institutions are all coming to us, because we've enabled that capability. This is not sending petabytes and exabytes of data to an LLM provider like they talked about, OpenAI, et cetera. This is actually running it local with the data, and that's the big game changer. On top of that, we made it hardware agnostic. You guys clap for NVIDIA. NVIDIA is a $3.5 trillion company. I don't love it because they own the market. We work with Intel, we work with AMD, we work with all of the silicon manufacturers, so we can really get precise in our service and solutions. So what you're actually going to see here is third-party applications, third-party agents that we validated to run on top of our stack, so that now you can have multiple different types of agents and services running on top of Kamiwaza. Kamiwaza accesses the LLM, the data, the security of the enterprise, and that's what you're going to see here, and that's what you're going to see with the Department of Homeland Security and a couple of other really cool use cases. The stack is quite large. It's 150 plus components. You got to build that one out there, Matt.
Scaling.
Yeah, it does take a minute. And it encompasses everything it takes to actually run off of this. This alone is quite an endeavor and adventure. This is what a lot of people sort of hack or do a little bit on their own. This is what we standardize so it works across the largest organizations in the world. This is deployable, like I said, anywhere in the world on almost any type of hardware across any type of solution. And if you don't want to use the internal model and you want to use an external model like an OpenAI or something, our routing will actually use the internal one to actually process the data, and then an external one to actually overview what the data was processed. And you can mix and match and get multiple services and LLMs fighting and really getting sort of the best of all value of it. So with that, I just wanted to make sure you guys understood what you were looking at. And now I'm going to pass it to Matt. Go ahead, man.
Wow. Look at that live demo. There's so much to show. Let me talk a little bit for a second and I want to frame what we built with the live demo piece and actually kind of tell you what I'm going to tell you in the context of agents, right? Because I do want to talk about agents. But this is the kind of Kamiwaza interface. What you can see here, there's a home page, there's a model repository, right? And you can do things like search for models. It does a Hugging Face integration. You can download some, and I'm not going to do that here and try to crush the Wi-Fi or anything locally or wait for it remotely. But you can see I've got Qwen 2.5 72B quantized to 4 bits up and running on one of our hosts in the cloud. I think I actually have, look at this. Now, isn't that interesting? So I toggled over my other Kamiwaza. This one's local. So you notice I'm getting the exact same interface, and this is running on my Mac. And I want to kind of frame this too, partially because part of our promise around being a deployable stack is that you're going to get consistent user experience, consistent APIs across platforms, whether it's local, because we have this community edition you can just download and use for free, whether you deploy it and run it in a big clustered mode. But we're built on top of a lot of really awesome technologies that are out there, like Ray. We use Ray Serve and Ray Data for data retrieval and distributed auto-scaling serving. There's all kinds of other open source technologies, Data Hub as a catalog layer, and so on and so forth. And like Luke said, we're this loosely coupled but opinionated stack. And opinionated here because not everybody's like you guys in this room, right? For every one of you, there's probably 500 enterprise developers that are out there, right? They're working on line of business applications and they're doing a ton of valuable stuff, but this is complete Greek to them still. And it shocks me how often I have conversations still with people who are, they're technology people, they're software developers, they're in the field. And you say, blah, 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 Claude, and they go, what? Like as if they've never heard the word. And you're just like, where are you? What rock are you under? How do you not know what's going on? But I'll say personally, I'm having the most fun I've had in a long career working on all this stuff. So couple other things to cover here. What you see going on in the user interface, and I could click on either of these, is all based on REST APIs under the hood, right? Meaning everything that you see going on the front end is 100% stateless. You're just getting a view of things that are going on the RESTful backend. So it's all just React in front. Now, one of the things that we really understood early on, I'm going to give us credit for this, was that while everybody was working on super fancy things, right, I'm going to have an agent that'll run a whole billion-dollar enterprise on its own. And we're definitely going to get there. But the thing that's in front of us is not that. It's what I call the car wash of AI. It's the most boring stuff. And we've now had enough contact with customers and enough working through things to realize that there are so many processes in a typical enterprise that are just so slow. It's kind of like that idea that, of course, 95% of statistics are made up on the spot. But it's that thing that 80% of data is still locked up in spreadsheets, right? Pick your number, but it's a lot of data. The world still runs on mainframes. It still runs on Excel, et cetera. You've never seen people get excited when somebody goes, could we use AI to extract these formulas from a spreadsheet? And you go, actually, yes. And they just they're like, this is the coolest thing I've ever heard of. Not run a billion-dollar company. Can I get it Excel with an agent? So one of the things that you have to worry about, though, in enterprise, of course, is how do you get consistency across many environments? How do you get that Docker-like experience, right, where it runs on my laptop, actually goes to production and works? Now, what you guys all probably understand in this room, too, is that the AI world of today is largely built on SaaS services, right? The giants of the space, the OpenAIs and Anthropics, even the togethers and the fireworks that are running on big SaaS services, all API endpoints. And so giving you consistency as a developer really matters. With that, I'm going to keep talking, and I'm going to take questions while I do it. And what I want to do, yeah, we'll see if this actually runs here. So we'll pick Kamiwaza. Earlier, I had a network problem. Does anybody want to give me a topic?
Topic to have an agent go out and research autonomously. Any topic. Popcorn, come on, guys.
RCCX theory. Tell me all about RCCX theory. Am I getting that right? Okay, this is going to be fun. I'm brainstorming. Now, this is an example of a couple of things I'm going to show. This is a project that just came out of Stanford, I think like a week or two ago, called Storm. A really fantastic, like autonomous multi-agent research thing. And even if this breaks, I have pre-canned ones that I did earlier that I can show you. And what you can see here, though, is that what this has done. Now, this is interesting. You'll see an interlink here. I'm running this app based on Streamlit on my Mac, but it's actually interfacing with my model that's running up on my cloud host. But I could be pointing it locally, but honestly, the cloud one's a lot faster. Macs are fantastic, but I can get like 600 tokens or something a second off the cloud host, so a little better to go there. So this is actually creating multiple personas. It creates a panel of experts that not only does it go out and search dozens or even hundreds of sources on the web, retrieve those and process them, then it has a whole panel of experts it creates that then has it debate things. And literally the first one I said, what are cheeses that are similar to manchego? And like there was a manchego creation expert that participated in this debate panel, right? So while we're doing that, I also want to mention that part of this is about being able to easily deploy apps, right? And this is a little less agentic, right? But again, we're coming back to that, like we deploy things in a way where it's super consistent. So this is, has anybody recognized this interface? Vercel AI chatbot. It's actually really, really good software. But what you'll notice is what we've done here is, and we have a blog up about this, about 10 to 20 lines of code you can integrate both with Kamiwaza's authentication system, which is how I'm logged in, as well as the model selector. You'll notice I've got that same model and port that we're seeing here in the models, right? Because it's literally coming from that API because the integration is fairly trivial. We'll let this run. Yeah, we'll come back to that. Now I got this other thing up too, and I'm going to have to make this one a lot bigger, I think. Yeah, we're going little command line here. This is localhost, right? And so you can see the Quen model that I showed you running locally. And what I'm going to do is I'm actually going to fire up Aider. Anybody used Aider before? No, this is actually pretty cool then. Doesn't like to stick with its pain. Okay, Aider is an autonomous coding agent. So now I have this running locally, right? This is local model. It's actually going to do inference in the Mac. I have a very beefy Mac. And it's going to do the local app. And I'm going to say to it, write me a fast API plus React app to manage sticky notes. Go. I don't know what it's going to do with my bracket. Seems like a bug. I should report that now. All right.
You can hear the Mac spin up.
I was going to say, we got the stat.
192 gig?
128, yeah.
128 M4.
I can't wait for the ultras. Then I'll run a Cram Llama 405 locally. Okay. I don't know if I have to reload this because of this weird bracket thing, but probably not because it's going really hard. We can actually see it running though. Oh, I interrupted it. Okay, let's try again. It's a rough user interface. Do it. If all you tell me is sure, you're fired. Well, the fan's going hard. All right, I'm gonna wait and let's see where it goes, and let's go see what the.
Told you we change it for engineers on the fly.
Yeah. Now take a look at this. So here we can actually see what's going on. And again, maybe I grow this.
Yeah, I think we need her to look at it. I don't think anyone else in the room knew what exactly this was.
Okay, so here we have finishing identifying perspective. So it's assembled this is our panel. This is our agents. Basic fact writer, geneticist, Dr. Emily Carter. I have no idea who is this. Do these people make any sense to you? Oh, nice. Endocrinologist. It's weird that it's actually, I've never actually seen it pick real people before, so that's kind of cool. Now, look at it go. So I have
all the websites it went out and grabbed information off of just from that autonomously by him putting that one line of code in.
Probably tons of people use Perplexity, right?
This is like Perplexity on steroids.
It's so it's the quality. Okay, the user interface is rough. It's like a week old, but wow, the quality of the production is so insane. I should have actually grabbed the graph, but it actually builds this sort of node tree of knowledge, right? Where it starts at a node, creates a set, and when it kind of gets to about 10 facts, oh, hey, synthesis complete. And it's even misspelled. I love these guys. So as it kind of overloads those nodes and has more than 10, it actually starts to fork it out. It builds this like ever-extending graph of knowledge, basically. Or I should say tree, because it's not really a graph, technically. Oh, show final article. Give it to me. So we built this live. Again, quality, but let me scroll down first so you can see what's coming up here, right? We are not playing, right? This is agents in action. Our panel of experts retrieved hundreds of articles and built. I have no idea what it's saying, by the way. I should have. Should I scroll around? You're the quality judge now. You volunteered. But it seems reasonable, right? It's not nonsense, is what I think we could say. And actually, I've seen this thing try so hard to write a good article, it kind of ran out of like token context before. This is fantastic, and I've done it. And actually, now that I'm here, let me see if I can go back one. And let's switch my articles. I don't know if I have to switch models to see that. Maybe I do. Let me click that. It's like it really doesn't want to show me my articles unless it's got an LLM to talk to. Is it this? I gotta shrink it just so I can see these. What kind of content does the Rocky Mountain AI interest group typically cover? This was my dry run earlier. I was like, let's see. Really cool, right? Look, what did we hear about earlier? Ken, AI ethics and safety coming up here as one of the topic matters. Super cool. I wonder if Ada ever managed to code anything. Oh yeah, let's take a look. Especially since Ader's breaking. It actually started to write right before I tested it. It was good. Might restart and see if we have time. I'm like, how's my clock?
You're fast.
Okay, that's so typical for me. Sorry. Where do I'm actually not 100% sure. Oh yeah, this is cool. You have to get them from the footnotes, and I'm not sure, it doesn't show the links after it's done, but you do get to see everybody's perspective. How cool is this? Like you actually see it has a dialogue Q&A where there's an interlocutor person who is basically asking the experts questions, right? This is the dialogue they had that produced the article. I love it. I wish I could find, will this load? No, it's dragging out the posts that came up, but not, I'm losing track of my tabs. Somewhere in there's the right thing. So I'm gonna let Emma take over. I'm kind of doing the happy hacker thing tonight, but I'm gonna hand it back because she is gonna cover a much more hardened use case that she spearheaded for us.
That is not live, thank God.
It went mostly fine. All right. You want to drive?
Yep.
Okay.
Yeah, that's.
You can right arrow.
Hi, everybody. I'm Emma White, a data scientist at GAI, Government Acquisitions, Inc. So we are a small business focused on providing boutique solutions for the government using our technology partners. Is it not?
No, you are. Matt was
Oh, okay. Fantastic. We've been around for about 30 years and just over 100 people. So we were approached, or I should say we were putting on an AI workshop for DHS when Sunny Westcott approached us with her theorem that low pressure systems are getting more intense and occurring more frequently.
What's Sunny's role?
Sunny is the chief meteorologist at DHS CISA. So fantastic person, smart, one of the smartest people in a room at any given time. So we are interested in taking agentic AI and seeing if it can help tell us a little bit about the data that we have available publicly for the last 90 years and creating a modernized workflow. So let's see, we're going to skip that one because Matt's gone over the Kamiwaza background a little bit. And right here is our data set that we're using. It's hosted at the Iowa State Archive. It's all GEMPACK data. The fun thing about GEMPACK data is that it is no longer being maintained by anybody. It was developed in the 80s by UCAR and NASA, and it's got tons of information in it. It's fabulous, but it's a niche data set and not fun to work with. So we used agentic AI, point and shoot, and gave it the website, some details about what we're trying to do, and said, go and download me 45 files from that. As you saw earlier, the layout of that structured website is not ideal to go and pull all of your data for the last 90 years. That'd be about 45,000 files. Not super fun to do on your free time. And here, the AI agent is running through our ask. It's pulling everything, it's checking its errors, it finds problems and keeps going without me having to step in at all. And I just had it do 45 files. It sees that it's only downloaded one, tries again, goes through, gets everything out. We actually had the entire 90 years of data downloaded, but
1.3 billion rows. How
Yeah.
many people here have ever used Devon or OpenHands, either one? Okay, yeah, this is OpenHands in action. We're checking out open source clone.
fabulous with the Kamiwaza running behind it,
So
essentially.
90 years, all of the meteoric data for low pressure systems, 1.3 billion rows. I can't even tell you how many trillions of actual data points. They did it all within about a weekend.
Yeah, a couple hours, right? 3 or so, and it pulled everything out.
Yeah, sometimes you have to help. We're like, hey, can you please make this multi-processing because this is
Yeah.
going to take a week. And then it was over in 3 hours.
It's fantastic. So it finds a solution to these problems when you go, okay, this is taking too long, fix it, let's go. The next thing we did here was ask it a little bit about the data. So as a data scientist, I'm interested in what's going on behind. I said, tell me a little bit about our data that we've moved to Parquet now. Tells me about the values, tells me which ones might be of interest to me. So since we're interested in these low pressure systems, I'm interested specifically in values called PMSL and ALTI. So here I'm going to ask it to give me a range of the ALTI and PSML values within our data frame. And I'm typing very fast too, as you can tell. And it's going to give me back the range, but it's also going to note that it looks like we have some impossible values in there. So it's going to be -9999. We don't want that pressure on Earth. That would be insane. And so it tells me that this is probably a null value standing in for when something couldn't be gathered correctly. So I say, okay, I still want to know the ranges. Tell me what the range is without all of that. And it gives me an answer within a couple seconds. And that's one of the beautiful things about agentic AI. Gave me an insight into the data without me having gone in and looked myself, and pulls back this corrected version for me where I can move on with my day a lot faster than if I was doing this manually.
Raise your hand if you'd be happy if you never wrote matplotlib code again in your life. Right?
No, I'm a data scientist. I do like matplot. So here's our updated ranges here, and it did that in seconds. This is all live. So this is a graph generated using the agentic AI. We're going to see the decades overlaid in lines here with the highs and the lows. Our older periods of time are going to be these more faded lines in the middle, and more recent years are going to be these darker lines. So you're probably seeing that the faded lines are all kind of clustered in the middle. They're not having a lot of variability, and then more recent years are having much more extreme variability. The highs are getting higher, the lows are getting lower, and they're happening quite a bit more. So this is our first step in seeing that Sunny's theorem is being upheld. The intensification of weather is happening, and because of that, older models based on weather may not be accurate and up to date for now, and they may not be able to tell us how to respond to these events. So this is our next generated graph. It was pulled using all of the data. It's the altimeter value over all time. Again, you're going to be seeing that over time, we're getting an intensification and more variability of these values across time. Now, more sensors are coming online, as time goes on. 1930s weren't really known for their weather sensors all over the US. In more recent times, we're seeing them everywhere at airports and things like that. So let's look at a single year. This was 2023 across the US, and we're seeing these intense pressure drops with these extreme lows. It's telling us everything we need to know. Things are intensifying. And you can see here with this single year visibility, look more into seasonality, are things happening more in the beginning, middle, end of the year, things like that. So the beauty about agentic AI is we asked it to generate these, it generated these, and then it can go out and generate these for more local areas. It can pull, year after year, so you can lay them out together, things like that. So this is going to be all right. So here is how we get a little bit into regionality. So I asked the AI agent to create a script that's going to go out and just for Florida, just since 2023, pull the 10 most intense or lowest lows of altimeter or PMSL values for that location. So builds a little box around Florida, pulls all of those values, finds the 10 lowest ones, and then I have it run another script that's going to go out and research related news articles based on date and location. So we can really connect these intense readings to real life events. So PMSL is, what is it? Pressure over, it's essentially pressure over C value, and then altimeter is pressure generally found at air bases, things like that. So these are the readings. They're important to pilots. They tell us, and another thing about weather, when a low pressure front rolls in, that's when you get weather. So anytime you see a hurricane, a snowstorm, things like that, that's all low pressure. Low pressure has been connected to certain human behaviors over time. You see intense low pressure and you might see a spike in crime, things like that. But the thing is, we already know that, but we don't know how weather is changing and how that's impacting our models from the past. So here, I'm going to go and click one of the links that's given to me by the AI for the past year based on Florida. Oh, look, it's Hurricane Milton. What a surprise that there was a huge pressure drop around that. So we're able to connect these.
That's the AI actually moving the cursor.
Let's talk real world for just 1 second too, and I'll just absorb even more time. One of the things that Sunny asked about that I just thought was so cool, because once people see this stuff working autonomously, the gears really start to turn. She's like, we have all these sensors. Could we build something that would see these things coming in real time? Because we can predict which directions they're going to move. Like, we have an early warning system, but it's really hard for us to kind of manually go and notify every state, every locality. Could we build something that would basically email them, text them, call them based on this information flowing? And we're like, absolutely, right? You just keep finding, these things. You build and build and build on them, because you can keep coming up with better and cooler use cases that stack and stack on what you do.
Yeah, and that's the fantastic thing. We're using a publicly available resource here. We're using a single data source, and we're finding all of this information already. If you plugged in a bunch of edge sensors that are pulling in things live, you'll get the same thing, and you'll be able to track weather, alert people, things like that, and we'll be able to respond better, prevent things like what happened in North Carolina and Charlottesville and things like that. So it's the idea that these AI agents take an idea that you throw at them and they keep moving forward. I didn't manage to get it into our video here, but I had a fabulous moment where I logged in, I start chatting with the AI agent because I'm getting to work again. And it says, oh, I noticed that you didn't have all of the data from the last few days. I haven't pulled that. And it just does that. I didn't have to ask it. It goes ahead and moves autonomously without me pushing that. And I thought that was fantastic, because that's another thing, is making sure everything is up to date day after day. So we are really happy with what we saw with you guys, and Sunny was very excited. So it's been just incredible to work with all of this.
It was that time we like let it run overnight and we come back and it's like built 100 graphs we didn't ask for. It's like, I was figuring out stuff to put on
I
here.
had to ask Matt, I said, did you go in and build all of these?
Easy
He's like, I
now.
didn't touch anything. I was like, okay, the AI agent's been working off on the side again, I see. And then one of the great things about the Kamiwaza platform is the ability to change the large language model underneath. This is me changing from Claude to GPT-4o, and I save and I'm done. I've just changed the model we're using, and I did that a bunch because, as you guys know, the model that you're using can matter. I found Claude to be better for some of our programming projects, and then GPT-4o better for maybe some natural language questions about the data.
And of course, if you put the hardware at it nowadays, the open source models will have kind of caught up with these. And if you guys haven't tried it, I will give a wholehearted endorsement for Qwen 2.5, Coder 32B. Like, I have a team that has access to every tool on the planet, and yet we frequently find that thing catching or doing things right where Claude might be getting it wrong, right? Not maybe the plurality of the time, but enough that it matters.
And here's a AI built little web app. So for people who don't want to build code and just want their graphs, they want to, go present them to people, tell them about it. This is what AI built in 2 days, basically.
Yeah, a little less than that.
A little less than 2 days. And it's writing all of the code underneath on the fly, querying the data on the fly. There's nothing pre-built in it. So here we ask it to add another line into our graph here. And we could have asked it anything to clamp the y-axis, to change the colors to red, to zoom in, zoom out, focus on certain areas. It'll do it. It does it on the fly, and the generation takes less than a second. So it's just fantastic how fast we're moving forward. So to recap, we were focused on, for DHS, CISA, are low pressure systems changing over time? Are they getting more intense? And based on our really preliminary dive into the data, yes, they are. We're seeing a lot more extremes occurring a lot more often. AI allowed our insights by autonomous data retrieval, data cleaning, and can help us with predictive climate strategies moving forward and maybe help people and how they respond to these events. So thank you for your time.
Yeah. Hopefully that was interesting. I will say the use that they're actually going to be putting that into, they're going to make it public. If you think about Disney, they manage parks. If you think about everybody that in football, that's a big stadium. There's a lot of public resources that actually are going to log into this portal. They're going to be able to say, all right, look at the weather that's coming towards them. They're going to be able to forecast the actual dip in the altimeter pressure, et cetera. And then they'll actually be able to tell people, last time it hit this pressure in our exact zip code on this exact day, it cost this much in damage. So we need to plan in this particular way. So it's actually taken sort of the fear of weather change, et cetera, and actually moving it towards this was historically what's happened, and this is now what we can predict what happened. It's a great use for the sort of government piece. And Matt, we're out of time, but I think you're just showing Ader here, right?
I was like, I still hear the fan going like so hard. It's got to be doing something, and sure enough, it's right in the code. So thank you, everybody.
Of AI agents is that it's somewhat amorphous. It started with something simple like just call tools and figure out, and a tool just being a function, and here's the right way to call it. They've gotten to be a little bit more complex in thought, like the Storm bot that goes out and calls multiple tools, but also makes decisions. And the decisions are really where I see the value in AI, or in agents. So to David's point about 10 people in a $1 billion unicorn company, I've heard it stated as a one person, right? And so you have agents that go out and they do all the things for you. You sort of come up with a business idea, or you don't let the agents do that, and they go out and they create other agents to be CMO, CRO, CTO, to be your salespeople, whatever, customer service. So then the idea becomes, what kind of business even allows that? Where do people want automation more than they want human voice? So if we start at the beginning, we have automation, and that's just sort of end-to-end sequence of code, and it accomplishes something. This is the RPA that David mentioned before. If you're familiar with make.com or Zapier, it'll be something along those lines. And it just goes, and if there's an error, it errors out, and you're lucky if it tells you. Then bots are sort of an LLM interface, like a chat GPT, combined with automation so that it can do something a little bit more intelligent. And they can extract content from emails for you. It can write blog posts for you. It can create outlines. It can do a number of these things, but they're all essentially a known sequence of events you're trying to get it to do, and the LLM is just a piece of that. And then when you get to an agent, you have decision making. And there's a couple of different types of basic decisions. The first one would be you have a series of tools. Which one do you use? Once you pick the tool, what are the right inputs? Then there's things like, okay, the user asked me this question. There's a bunch of sort of inferred questions behind that. It's not just the question that I've given you. There's a whole bunch of things, context that we sort of forget to bother to pass on. You can have an agent figure that out for you to a certain extent, and then make a decision based on that broader context about what you actually want. So you're writing the report again. It comes up with a better report for the fact that it's decided here are the implied questions. And so when you add this decision making, you start to get into the idea that the agent can do things on its own, sort of like the over the weekend doing the reporting, right? All the visualizations and whatnot. It made its own decision about what the right thing was to produce, and then it sort of learned from it and went on to the next thing. And so, like I said, highlight here, agents are bots plus decision making for real value. Having spent the last couple of months working with a lot of the open source projects, I was really hoping to find one I could just build on top of. And there's some that are pretty decent. Langroid's probably my favorite. But when we get right down to it, the whole space is immature and it's changing very rapidly. And you have a couple of different problems. So the good projects, you've got lots of them, but they've got good documentation. They've got fairly straightforward interface. They don't try and do too much for you. The bad ones, they're simple, they're trivial, they don't really do much except sort of wrap an LLM, and then because of the architecture they've chosen, they limit your choices. And so you actually lose functionality for using some of them. You also have the problem of key features being broken or completely missing. I ran into this right at the end here when I was looking at Crew.ai. Their little line for plugging in RAG databases and knowledge was broken, and they just had a GitHub issue that said, we'll get to it later. So I hope you don't need that. You can find out the hard way. And then the really ugly ones, you have sort of the combination of bad and missing features, but you also have them doing things like importing LangChain for 4 files, right? You've imported the entire thing, and the LangChain community and dozens of projects get imported, thousands of files. You've used 4 of them. And along the way, you've created a whole slew of problems for whatever you're trying to build downstream. So you don't really, that's something to avoid. It's not that I hate LangChain or anything. I don't love it, but it's not, you just don't want all those dependencies coming with it if you're building your own project. So if you're a technical person looking to build these, that would not be my first choice. Again, myself, I don't those CU logos not showing up. Quick thing, I started my career in aerospace after graduating from CU. Worked in aerospace, pointing lasers at things, and got a degree in controls to point lasers better. And then about 2009, went into the digital marketing field and owned online companies here and there since. Currently doing fractional chief AI officer stuff. And 20 years of building on the cloud, desktop, mostly Python in the last 10 years, but several other languages in the past. We'll move on because we don't really need that. All right, so sort of rehashing a little bit of the good and the bad from these projects. Some have solid documentation. Again, something like Langroid comes from, I think it's Carnegie Mellon. It's a university-based project. It's got probably a bunch of unpaid master's students working on it, but the documentation's there, right? They will detail things out. They've got lots of examples for you to follow. they have a pretty solid framework. I didn't choose to go forward with it for my demo and some of my client projects because getting citations out, it seems to be nearly impossible. You can watch it, so like that log file that I showed you before, that when things are running, I can see what data it pulled, and I can see that it's doing the citations and pulling the right data. I can read that data. I can see that it's pulled the right sources and it's used it for whatever answer it's given me. But I can't get it to the UI where the user can see it. And so if you're going to trust your AI, especially when you're first pulling up a new tool and you're using it for the first time or the first couple of months, I don't know about you, but I absolutely want to see those citations. I want to be able to read them just like Notebook LM has on Google's Notebook LM. Hover up with a little one or two and you can see the blurb. Because they hallucinate like crazy. And especially with sources, if you ask for sources and you don't have something to double check them, there's a good chance they're hallucinated, at least a large percentage of them. So again, back to the good signs. Langroid's got a lot of good things to it. That's like the one Achilles heel for it. It's got solid documentation, it's got integrations to it, a number of tools and vector databases. And then it has, with their extensive logging, quite a bit of observability. So the idea that you can see what's happening in the background and watch it as a developer and make sure that it's actually not just wandering off into the weeds. And then on the projects to avoid, again, this is for open source projects. Anything with long chain and llama index. Again, this isn't so much a personal thing as it is just like they're changing all the time. They've got a lot of sort of extraneous stuff. They've got a lot of community code input that isn't well tested before it goes live, and that causes other dependency problems, and just is constantly breaking things. So just avoid it if you can. The other ones, you see a fair number of projects out there with examples that they provide for you. Super simple. That suggests that they don't have a lot of functionality, and you're probably better off just building your own, especially with something like Claude that can take a couple of days. I guess we can do Q&A. That's certainly.
A quick question, so many early agents were built with LangChain, LangChain, LangGraph, all that stuff. Product that I was building, 6 months ago was using all of that stuff.
Yep.
You're just saying, don't even use it, don't touch it now? It's a little bit.
Yes, I am. Again, I never built anything with it in the first place because I found too many problems too early on. Generally, again, dependency issues. And then the early versions of it, they had too many levels of abstraction. So changing any config value was like dig, and then you find this thing way down deep in the bowels, and you pull it all up, and then you gotta pass it back down the 15 layers of the bowels, and then that creates problems. Now, they're chaining, and they've definitely gotten better, but the chaining is kind of a unique thing that, it's like pipelines out of sci-fi and whatnot. I'm more interested probably in that lane graph when I feel like it's mature enough to go look at it again. Llama Index, on the other side, they also have sort of the same thing where there's a ton of community projects or plugins going in, and they have the same sort of issue where you get dependencies that kind of pull in and conflict, and then you have problems down the road, and a lot of this stuff isn't well tested. So you think you can use it, and then no, I gotta go fix it. Well, if I gotta fix very much in LangChain, I'm just building my own things. There's too many things that LangChain limits me in, and too many problems that come with it to bother building with it if I gotta go fix things. So, yes, I would suggest that if and this is exactly the process I followed once I found that I didn't like really any of the open source tools. I shouldn't say I didn't think they were mature enough. And that was, I went and I looked at a whole bunch of them, and I saw what features they were suggesting, what features they didn't have, and where were they going with things like memory for the agent versus just a RAG database or something along those lines. And then what do I then want in my tool going forward? And especially, as I mentioned before, I use Claude for a lot of this stuff. you can spin up a lot of these things in a couple of weeks. There's not really a reason to use somebody else's tool if it's not perfect. So that's ultimately what I would suggest to anybody looking to build one of these is take a look at the bigger projects, like a lane channel on Index, see what people like about it, what they don't like about it. Look at the memory projects like Mem0 and MemGPT, which is now Letta. Play around with FlowWise. Play around with Letta's got their own UI for that stuff now. Play around with some of that stuff and get a feel for what you really want and where they break, where they don't give you what you want. Like Langroid not giving me my citations, right? Like that is, I have to have that, period. So I gotta move on. But everything else about that library I liked quite a bit. So, like I said, I would recommend looking, do a little quick survey, build your own. Use Claude, use Aider, use whatever you like, but there's a lot of LLMs out there that'll help you build this stuff really fast. So, question is 2025 the year we see the first one-person, $1 billion company? It's probably a little early in my opinion, but I wouldn't be surprised either. I think it depends on finding the right product in the right market, where people are expecting and want the automation over human interaction and customer support. Key takeaways here. Agents are hard to get right. As many people who have tried to get JSON out of an LLM have found, it's not super consistent. Even you get into the OpenAI, and you tell it it's got to be a JSON format, and you still get JSON that's not right, and you still got to fix it. And every single time you pull in something like that, you have like 8 try except blocks to try and catch all the different errors that come out of it. They're not easy. They need some babysitting. They need some people a man in the loop per se. There has been a lot of work. And like I said, to sum up, every one of these frameworks has some sort of serious flaw or is just bringing too much stuff in it doesn't really need, as opposed to rebuilding some things to limit the number of dependencies. Let me get to the third bullet and I'll be happy to answer some questions here. And then I think, teams of agents are where we're going to get to really useful AI. And the reason for that being that let's take a sort of an example from the vector databases in the RAG-DB again. If you give your RAG, you have like 3 different databases that are all on very distinctly different topics. One's on baseball, one's on weather, one's on Chinese food, right? When you ask a question, the LLM's not going to have any problem figuring out which database to go to or which one of the, or if none of the 3 are useful. If you start having lots of choices, and they start to bleed a little bit, now the LLM has a harder time figuring out what the right thing, what the right database is and what the right question is to take your query and turn it into a database query. I think the same thing is going to apply to agents, right? For all these decisions, you want to keep them to like 3 to 5 options, probably 5 at the top end. Maybe you can push 7. You want them to be fairly straightforward options and fairly distinct from each other. As a result, if you want an agent to do complex work for you, you have to be able to take that work and sort of break it into simpler tasks and field sort of a tree or a team of agents that interact with each other and do simple jobs and bring back the answer. So that is where I see the agent architecture going. I have a couple more slides, but if we
No. So
No? Okay,
we
let's-
have about 5 minutes on this presentation, then we'll do group Q&A. So
Okay.
please hold the questions.
My bad. So this is from the Storm paper, talking about how the Storm bots interact. What I tried to build was sort of the one on the top, not the one on the bottom with direct human interaction in the process. And so the steps are that you ask a question, it goes through brainstorming, talks about different perspectives on the topic, and tries to come back and forth, comes up with a whole series of questions and topics that need to be answered. Those get sent off to the research bot. The research bot answers each question one at a time. That might be Wikipedia, it might be a Google search, it might be a vector database, it might be something else, right? After it's acquired all that data, it then takes the data and sends it to a report generator, which is a third agent. And that agent takes all that data and writes the report per your instructions, and spits that report back out. Now, the decisions here are, each one of mine have what's called self-reflection in it, where it goes and it creates an answer, and then at the end it says, is that a good enough answer? And if it answers no, it comes back with improvements, and then we run the loop again. We do that a few times, right? So that's what the brainstorming agent, that's all the decision making it really does. Down at the research level, it has that self-reflection mode. It also has tool options that it has to choose from. So it chooses which tool to use and which thing to then go ask for from that tool. And then, an obvious next step would be to have it then create another depth of research if that's what you wanted to do. We did the surface, now we have a bunch of questions answered. Are those the questions that we actually need answered for the final report, or do we need to go another layer deeper in our research? Have it make that decision. But then we get down to the report generator, and again, you're doing lots of summarization, lots of self-reflection. Is this good enough? Does this need extra content? Does this need, whatever. And along the way, you're trying to keep your citations intact so that when you get your report out, you have something useful. This is an eye chart, but what it really is this is the visualization of running the bot storm, or the storm agents, all the way from the beginning to the end. This is all the different things they called and all the different ways it got called. So this is like the agents calling each other, the agents calling the functions within the agents, the tools they've called, how many times they've called them. This is what happens to produce one report that's like a page and a half long, right? So it's done a whole bunch of stuff. Now, I'm trying to get it to be longer, but still, it's like this is a ton of work that it's done in the background. It's done it for 10 or 15 minutes to run, cost about 50 cents in OpenAI tokens. And I just basically present this so that these things are doing a lot of stuff in the background, and it's not going to be, it's not trivial to keep them doing all of that without some error or something happening in there. So this is a QR code for my LinkedIn if you care to get linked. So I think that's a wrap.